Hello and welcome to our next workflow demonstration. This time I'm going to use Solidworks and QUICKSURFACE for Solidworks plugin. So for users who are not familiar with this product, this is plugin for Solidworks that enables Solidworks options to work with scan data. Basically, you can import any scan data into your Solidworks environment. And after that, you can just use very similar tools as we have in our QUICKSURFACE standalone software. So we can edit scan data, we can extract primitives, we can reposition our scan data to coordinate system, so we can fit surfaces, we can do some automatic surfacing, create freeform surfaces, same as create cross-section sketches that are later used for creating geometries with native SolidWorks tools. Of course, we have all the deviation analysis included here. So in short, that would be everything related to this product. So as we have imported our scan data, we can take a look at the info. So this current one is like 10 millions of triangles, which is quite a lot for this part. And we can see scan data actually is quite rough. So what I'm going to do first, I'm going to tools and I'm going to decimate this because I don't want to use 10 millions of triangles. It's quite pointless. This is just gives much more load for the system. And here we can actually input value that we want to keep after decimation. So for example, if we decimate by 50%, we will end up with 5+ millions. If we click preview here, software will calculate this decimation and you will actually be able to see deviation, how the decimated mesh looks in comparison to original mesh. So here we can see deviation between original mesh and decimated one. So as we can see, we have intolerance 99.999% of points. That means we can go way lower. For example, set this to 10%. Okay, so here we can see result of decimation where we keep only 10% of initial triangles, and here we can see the slight deviation in super small areas. Current tolerance is set to like 0.01, so if we will change this to 0.1, most likely we won't see any deviation changes here. So that means we're very good to go with just 10% of initial triangles. One thing to consider here is following. If you have super small features, geometries, for example, like probably part numbers on casting parts or some embossed part numbers on plastic parts, if you decimate them too much, this may lead to making them a little bit more blurred. So probably if you have such features, you can consider to keep original mesh or part of original mesh to later be able to reproduce these part numbers or super small features. Otherwise, this is way to go, because currently you can see we have just 1 million instead of 10 millions of triangles, and this will save some sweat of your system hardware. So once we have done the decimation, as a first step, of course, I'm going to do extracting of primitives. And here in this case, okay, overall this mesh is quite rough. You can see, so all these regions, we don't want to use them to fit our primitives, because this will lead to some unwanted deviation from original. So I'm going to look for smoother parts of this scan, like this region here. Probably I can select something here as well. This looks good to me. Probably this part. Okay, this one as well. Something here. Oh, maybe something here as well. So, okay, I have selected these triangles and set to create cylinder here. So we'll enable deviation analysis. So we can see that we're pretty good. On both sides, it looks like equally fine. So I'm going to accept this and create just reference axis. So we have axis for our bearings, and I need axis for this main axle here. And let's see, I guess I'm just going to use polygonal selection tool with settings select through, and just select these triangles right here. Say I want to fit cylinder here, check the deviation. Okay, looks good again. So create another reference axis. Once we have completed this, we can go to align our scan data by reference. I'm going to use this axis as Y and this as X-axis. Here we can see the preview of how it's going to look in aligned way to our coordinate system. Click OK, accept. Okay, so here we are, and now we can see front view looks good, top view, so everything looks fine. At this point we can just come over here and delete all these construction geometries and start our reverse engineering task. As a first feature, I'm going to recreate this main body of our axle, basically the geometry that we are interested the most right now. Because, for example, the lower part is a super simple geometry, and this requires very basic skills to reverse engineer it. So in order to reverse engineer main body, what I need first of all to create axis here, vertical axis, and I'm going to use this to create the world cross section. So at this point, we just have to rotate our cross section plane to desired location. So a little more insight about this. Since this is a casting part, it was made from two molds, one from one side, another from another side, and here we can actually see the split line of molds. Normally this leaves some unwanted geometry, and we can see in this case also it was there, and later it was just grinded away. So we don't want to use this region of our scan data to define our outer boundaries for revolve. So I'm just going to move it probably somewhere here, so I get most of geometry captured. And I'm going to create this on slicing plane. So this will create us new plane exactly in direction where we left it. And we have our cross-section slice points here. So as the next step, we come over to this plane, click on sketch. We can use this plane to enable section view like this. And now we can proceed with fitting entities to our slice points. So come over to QUICKSURFACE tab, fit sketch entities. So here we have options to enable instant fit. In this case, it should work very well. So I can see that here, most likely I have one line, and here it looks like another straight line. So after I have fitted these two, I can just hold Ctrl and connect these two line endpoints. So this intersects our two lines. After that, I can hold Ctrl again and brush over this corner, so it adds automatic fillet calculated by scan data. And at this point we can see that actually this doesn't fit too well here. So I'm going to undo this. And let's see, I can try to fit another straight line here, connect these two, fillet, connect these two, fillet. Now it looks quite decent. So on this side, I can fit straight line here, intersect them, create fillet. Probably I can continue straight away with these as well. And this fitting line here, connect, fillet, connect, fillet, like this. Okay, so after I have done this, click OK. We end up with a native Solidworks sketch where we can come over and edit everything that we want to edit here. So I want to say this is a vertical line. Probably I want to reposition it. Something like this. Okay, and I want to extend this side here. I want to connect this to our revolving axis, and I want to add one more line here to create a complete boundary for revolve both and axis of revolution. Okay, so we see at this point we don't have the preview of our revolve. So here's the problem, that in SolidWorks we have to create another extra line here that follows our axis to define complete boundaries. And now we can see that we have this preview. Let's accept this. Let's disable our section and see our comparison result. Deviation analysis shows we're very close everywhere. So I'm just going to leave it as it is right now. Now we can come over, hide our cross-section sketch. We won't need this anymore. Let's hide our solid body. For now, I don't need this axis as well. So what we need now, we actually have to create this cutout and cut our revolve in this direction as well. So in order to do that, let's see. It seems pretty much planar. So we have two options. We can fit plane here, or we can come over the side view. So I want to create cross section here. And I want to use outline option to capture complete geometry of our scan data. So like this, we have this nice result here. Click accept. Right plane, create sketch. Again, we can make section view to have more representation. So now again, we are going to fit sketch entities tab. And let's fit line here. SN. Let's say that's it for now, because since this is a part that's rotating, I want to keep it uniform across both sides, symmetrical as possible. So I'm just going to mirror this entity to the opposite side. You can see this fitment is a little bit probably off, but well, this might be due to wear of this part, or probably it's slightly deformed. So we want to keep this consistent as possible, so we're just mirroring these parts and considering this side is like nominal value for this. As next, again, I'm just going to create a circle here. Actually, here we can see that it's not just a circle in this case, so I'm going to fit entities tab and I'm going to select these points. Okay, and now I want to reposition this circle to have center on our axis, something like this. And after that, I want to tell this is like not completely coincident right now, so let's say let's just extend these two lines and say our circle is tangent to these lines. Okay, and at this point we can see that we are a bit off our scan data, so let's just reposition our circle to match the top part of it, like this. Let's go to trim entities, so we can use the power trim. And it's something like this, so we have a complete profile here. Okay, and now I want to extract another entity here. This. Again, come over to Sketch tab and mirror them. Okay, good to go. Now we can go to our corner trim to intersect them. Same on this side. Okay, and let's just extend them. So something like this. Considering SolidWorks tools, we can come over to our Surfaces tab, click on Extrude Surface. So let's make this mid-plane, extend it more than we need. Click OK. Let's get out of our section view and hide our solid. Okay, good. At this point we can Again, hide our cross section, and in surfaces tab we have this feature cut with surface. So we select our surface, and normally we do see this arrow. This indicates direction of cut. Well, in this case we need this opposite, so we want to remove this part of our solid. Click OK. Now we can hide our surface bodies, and we end up with our trimmed solid. So here again we can see that deviation isn't completely perfect, so at this point we can consider to go back to our sketch. So as we are in our sketch, so we can consider to reposition some of our entities here. And in this case, I think I'm going to lock just these two endpoints of our line, and then we're going to change dimension of our circle. So I want to make it slightly smaller. Let's say I want to make it 21 millimeter. And we can see that we have here already some more cutting from our solid body, and it's closer to our scan. So I'm going to reposition this a little bit higher. And accept. And let's see how it looks like now. Okay, so now we're quite close on one side, a little bit more on the other side, but as we noticed previously that this side is a bit off in our scan. So we're just going to consider this side as a nominal side and going to use this as a reference for our designing. So once we have done this, we can hide our solid again. Now we want to use front plane. Click on create cross sections, again using outline mesh option. Okay, so we have this our nice outline right here. Accept this, go to front plane, start sketch. Again, we can create section here. So here we can see that on one side we have some features better visible, on the other side other features. In general, I want to fit here one line. Let's fit here another line. Considering quality of our scan data, probably I'm going to fit some of these entities just manually. So something like this. Let's fit another line here. Intersect these two, intersect these two. And then need another line somewhere here. So at this point, this is like a little bit of eyeballing, just considering quality of the scan data. Probably this is the way to go approach, since we have this deviation analysis later, so we can understand how good it fits or not. We can later come over back to our sketch and reposition our entities to get better results. And I want to fit another. I want to fit an arc here. Like this. Okay, so okay, let's make this as a tangent. Pull it down. Like this. And line at the end of this arc says tangent. Then we can come over and trim away this one. Again, I want to create here axis for mirroring. So select everything, mirror entities. Like this, and actually I want to cut away this part as well. So let's fit an arc here. Go to our sketch tab, again trim entities, corner trim, intersect them. Okay, good. Again, I want to come over to mirror this arc and intersect these two. Let's see. Okay, I can intersect these two as well. So at the moment, as we can see, here is some drilled hole. So this geometry is good enough for us. I'm just going to extrude the surface again. Mid plane, like this. Hide our solid body. Hide our cross sections. And cut with surface. So this time indicator shows in the correct direction, except hide our surface cutter, and we end up with this result. So let's see how it looks like in our deviation analysis. And we can see that we are pretty close on most of the sides. So let's say this is good enough for our case. Okay, so following thing, we need to extract a couple more surfaces here. So we need either to fit here. So let's try to fit here a sphere. Maybe this will make our life way easier. Okay, so I want to fit here sphere and see, okay, deviation shows that it's not actually a sphere, so cancel this. We have to find for a different approach. So in general, we can try to create like a cross sections here and sweep this, but to save time and have some more flexibility, actually we can fit surface here as well. So let's again select this region. This. Okay, and I want to fit here surface. Surface deviation, let's set to 0.1. You can see it fits quite well. Let's accept this one and hide our solid body, and well, okay, we can see that in general we would have to extend this surface. And here's the problem with fitted surface. So as we want to extend this, it tries to just warp in all possible directions. If we set this to linear, it gets a little bit better, but still it sort of doesn't end up in places where we would like it to be. So let's cancel this. I'm just going to hide this for now. So fit surface is not a great plan as well. So what I'm going to do right now is just deselect these triangles. Okay, on this side it seems much better. So I am going to fit a new freeform here. Let's place our first polygon. So let's fit our first polygon. Something like this. Should work fine. Okay, we can enable real-time deviation right now. And essentially what I want to do, actually I want to first of all extend this side. Disable our snapping, but probably maybe not yet. Maybe at this case I'm going to use still snapping on and reposition our points of our freeform to match our shape better. Only reposition this one, maybe this one a bit. And now I want to split these edges in half. So this moment I can see here we have higher deviation, and on this side it's not that great. But first of all, again, since this is a revolving part, I want to have symmetry on both sides of our axis. So I'm coming to symmetry. This should be right plane. Okay. Now I can select this edge and say place on symmetry plane. So at this moment we have created this freeform surfaces, like sort of mirrored. On the other side it's symmetrical, and we have good continuity on the connection here. But we can see we have some slight changes in deviation. So what we do, we can come over here to reposition this, or just use here option snap to mesh. So I'm going to select all these points, snap them back. And after this, I want to start to reposition these middle points probably in order to get better deviation. Something like this, and probably I need to snap this one back. Okay, so actually here we can see we're pretty good right now. And I'm just going to leave it like this. And now I'm coming over here to extend our freeform. Extend in this direction as well, and we need to extend it in this direction also. So at this point we can see that actually extending of this freeform created some sort of mess. Let's accept this. Let's hide scans. Come over here to edit, and what I want to do, I want to snapping currently is off because we don't have any visible meshes right now. So in this case we can try to select this edge and smooth it. to get nice and smooth surface. Let's bring our scan data back, and probably I want to unhide my solid right now. So I want the surface to end actually here, just before corner of our solid. So I can easily do this by repositioning these points of freeform surface. So now it looks good enough for us. Okay, I'm going to accept this result. Okay, once we have this surface created, we need to trim this away from our main solid body. How can we proceed to this? So based on previous actions, logical would be to come over this quad surface, set cut with surface, and click OK. But well, this doesn't work just because Solidworks doesn't have same trimming tools as we have in our software, in our standalone software. That might be done there just absolutely easily. So we will need some different approach here. And in order to do that, let me see first, let me hide my solid body. Actually, I can see here I want to slightly adapt this quad surface to match my scan data better. So let's see the real deviation. Select this edge. Let's just pull it a little bit inside like this. So we have this corner matching much better. Okay, accept. And we're back here. So how to proceed with this? I'm going to show you one cool trick that comes from surfacing stuff. So I'm going to offset surface tool, select surfaces of my body, set distance to 0, accept. Well, now I can hide my solid body, and I have duplicated basically these surfaces. So let's hide scans. Basically, if I trim all these surfaces, I will end up with solid that I can later subtract from my main body. So we go to our surfaces tab, trim surface. We have to select our trim tool. I'm going to use this one, and now I have to select surfaces that I want to remove. These will be these. And now in opposite direction, like this. So I have these two nice surfaces. So in order to get them as a solid, I have to select all of them and knit them. With create solid option enabled, we can enable merge entities option as well. Then we have another solid created. So at this point, I want to mirror this cutter solid to opposite side. I'm going to use front plane as a mirror plane like this. Click OK, and now I need combine tool. So here I have to select my main body and bodies to combine. So this one and this one. Make sure it's subtract and click OK. Done. So this is how we can recreate this geometry right here. So we can unhide our scans. Let's compare results. Okay, looks quite decent here, but we can see that here we are still missing something. So let's hide our bodies and try to understand what actually do we need there. This doesn't look like a normal fillet here. It reminds more something as a variable chamfer. But just to simplify things, I think I'm going to create just another freeform surface. Let's say based here, here, and somewhere here. So now I want to split these two edges. Maybe slightly reposition this. Okay, it looks good right now. So now, what I want to do now, again, I want to make it symmetric on both sides. So I'm going to symmetry option, right plane, like this. And I want to set, okay, let's set this edge on symmetry plane, and let's split it here again. But okay, at this moment this snapped back. So what we're going to do, we're going first to no, let's not extrapolate this. Let's just select this edge and disable snapping. Let's set this to world, and by holding Alt and dragging it away, we're creating new polygon here. And at this moment we can use this new edge to connect them and create symmetry. Also, we can come over and pull this edge a little down. So we're getting closer to our deviation. Probably we want to pull this a little bit down as well. So something like this. And now we can proceed with extrapolation of this surface to extend it in all the necessary directions. So, like this. Click OK. So we have created another surface that we want to cut away. At this moment we can actually try to use cut with surface option and see if that works out or no. Okay, in this case it worked out, so we can hide this and we can actually mirror our feature. Let's say front plane. Okay, good. So we have created this, but here we can see that we have this little nasty corner that doesn't look like it should. So let's go back to our quad surface and let's slightly reposition this edge and slightly reposition this edge like this. Okay, except nice, now it looks perfect. So as a next step here, we can actually add some first fillets. Let's select this edge and this one. Of course, we don't need so huge value here. We want to use something smaller. At this point, we don't have any much control of deviation from our solid body to scan body. So what we can do, we can accept this. We can enable from features tab instant 3D option. we can come over to Quick Surface tab and enable Instant Compare. So here we can see deviation of solid body to our scan data. And if we come over, for example, here to our last made fillet, we can start to and we're getting instant update of deviation analysis to our scan data. So at this point it looks, it might be close to like 4 millimeters like this. So we can run like complete deviation analysis and it looks very well. Okay, we can see at this point again there is something tiny bit wrong with our quad surface, so we can come over, edit this again. Let's hide bodies and enable real-time deviation. Okay, so now we have to move something here more, but since we repositioned it to have a nice corner, I don't want to move complete edge. So most likely I'm going to use just 2 of these. And maybe a little bit this edge, like that. Okay, let's see the deviation. Okay, we are much better right now. Okay, cool. So this is one off step and we have good geometry here. So basically now we need this drilled hole here. In order to do that, again, we have to go to our, let's unhide our axis. Use this axis for cross section. And in this case, I have the most geometry on approximately 90 degrees from plane. So I can come over and set here this to 90 and create on slicing plane. Accept this. So since 90 degrees is our front plane, software didn't create our extra plane for us. We go to front plane, click create cross section sketch, and let's come over and fit some entities here. So I'm going to instant fit this like this. Okay, I'm going just to close them. So something like this. And here I can see it. This line is not completely vertical, but I want this to be vertical. So that there is like a negative angle there. So most likely this is the just issues of scan data. Let's connect them here. Extend this line. And add some more lines to close boundary. Okay, good. So now we can create, actually we can create instantly revolve cut here, like this. In order this to work, we have to unhide our solid body. And click OK. So let's hide right now our cross section and see actual result. Again, this looks good. So now we can proceed to creating our not completely last features, but actually close to that. I'm going to hide axis again. I will go to right plane, create cross section. Now I'm going just to reposition plane so I can capture the outside of this feature. Something like this should work just fine. And let's create a sketch here. I'm just going to hide bodies so I can see much better. So in this case, I have to fit new circle here. But as we can see, it doesn't align most likely with our previously created solid. So in this case, what we want to do, I want to actually reposition center of my circle to axis. Lock it at the moment. Let's see what extrude gives us in this case. Let's show our scan data. I'm just going to disable this instant 3D option. I want to extrude this in 2 directions. And I want to add some draft. This, so let's see. Here we can start see our geometry already. So this looks like around 4 degrees of draft. Something like this. At this moment, I'm just going to accept this extrusion, and okay, here now I can see that we don't have very well matching geometries. Let's see what deviation analysis shows us. Okay, we're very good here. Quite good there. So in this case, we have to figure out some solution how to solve this, and let's get rid of our cross sections, and actually let's come over to edit our extrusion and set direction to up to this body, like this. Let's accept this. Now we can come over to enable our instant 3D, instant compare. We just click on this face and start to drag it back until we start to see the good deviation. This is something close to this. And I'm going to accept this. Just disable instant 3D and disable instant compare. So now in order to get rid of this edge and at the same moment to obtain fillet on this side, I'm going to add fillet here and just see how this will work. Let's see, 3 millimeters. It seems that we need slightly more. So we can go to our fillet and change this for for example, to 4 millimeters and see the result. Okay, this result is quite good for general shape. And I'm going just to stick with this result. So now I need the same feature on the other side. Again, I can come over to mirror option. I have to select mirror plane, and I want to select features to mirror. So basically I need this boss extrude and I need this fillet. Click OK. Good. Worked out. So perfect. As next feature, I want to recreate seats for bearings in this axle. So in order to do that, I will create sketch on right plane. I will hide bodies right now. And since we were creating everything based on center point of our coordinate system, I'm just going to use simple circle here. To match scan data. And considering we had some deformation of this part, previously we already saw that it's a little bit off to the sides. So I'm just going to use the center point to create my circle, and I'm going to make it as 30 millimeters and make this as a extruded cut. Like this. And hide my solid bodies and click OK. Let's see the deviation analysis. So we can see the top side of this seat and the bottom side is very well aligned, but we have this sideways deviation. As long as the sideways deviation outside of this part, and this is because the actual part is a little bit sort of twisted, deformed to one side in comparison to axis of this axle. So these are the things that always you will have to consider when you're working with some older parts that have been used. These problems can occur always, and you just have to think logically how to create the correct model so it's straight, so it's perpendicular. Not always scan data shows us the correct part. Basically, the scan data is a canvas that we can use to recreate our part, and we have to consider many things, same as these deformations. Okay, once we have done this far, we can start to add some more fillets here. So let's add fillet here on this side. Let's make it smaller. Okay, probably 2 millimeters looks decent for me. Let's see the deviation. It looks just fine, but if we hide a scan data, we can see actually here this fillet isn't like completely straight profile because it was created between these two edges. This fillet is not what we would like to see here. So in order to make it proper, let's get rid of this fillet. Let's roll back before we created this opening for bearings, and add fillet at this point right now. Okay, and then just roll back, and we can see that it's now completely uniform fillet. This is what we wanted to achieve here. So let's show our scan data and compare. Okay, now we can see that we want to add some more fillet on this edge, and we have something wrong going on this side here. So let's try to add here fillet. Obviously we need something more than 2. Let's make it, for example, 3 millimeters right now. Run comparison. Okay, so we see that still it's slightly wrong. And what actually, let's hide bodies and let's try to understand what is wrong here. So basically here it doesn't look like we should have the planar surface here as we have it currently. So in order to resolve this, we would have to go back until our first revolve here. Let's edit this and let's get rid of all these lines. Let's extend this one. So like this, and connect these two. Okay, we have some errors right now of our last fillet, so that's absolutely fine. And we want to get rid overall of this flat surface here. So here we can see that it's a surface cut and it's made from this sketch right here. And what I want to do, I want to get rid of these two lines. Now I'm going just to fix these and extend so they protrude complete part. Okay, so now we're at this stage and I'm going to create another revolve here and hopefully that will sort our issues. So again, let's create sketch. It's sketch entities, straight line here, straight line here. Not that straight here, and last one here. So let's intersect and fillet, and obviously we need some line on that side as well. Let's accept this sketch line. Corner trim these. Okay. Actually, I will create fillets just a tiny bit later, straight after I will create a revolve feature. So again, connecting these lines to axis. Let's say this one as well. close the boundary and make a revolve. Okay, let's keep it this unmerged, and let's see comparison. Okay, good. So we're now much better than we were previously. So this means now we can hide our cross sections, hide this axis for now. Let's find combine tool, add this one and this one. Good, so we have again just one single solid, and from this point we can start to add more fillets here. Like I would like to create fillet here to match the shape. So probably something around 5 millimeters. Let's see, compare. Probably we can try to make it bigger than just 5. Let's make it 6. Let's see what we can find out with our instant compare tool. So it's something close to 8. Okay, good. Okay, so now we have done that. We want to add another fillet here, and we want to add another fillet on this side. Let's make it something smaller, like 3 millimeters. So basically here, when you're creating these fillets, you can actually aim against this edge where scan data meets your solid, and this will be just quite close to the actual result that you want to achieve here. Okay, so we have created that one as well, and I want to add a couple more fillets. So one would be here on both sides. Probably same 3 millimeters. It looks like we need something just a tiny bit more. Let's make it just 4. Okay, 4 looks good. So once we have added our fillets, I want to recreate now this axis, not axis but geometry of this axle. So I'm going to create another cross-section sketch here. And rotate it just slightly to capture outer geometry of these tooths, of these splines. Okay, something like this looks good. Create on slicing plane. Accept this. So we're going to this new created plane. Let's enable section view. At this moment I can hide planes, so it just doesn't bother me. So fit entities here, here, and probably somewhere here. So let's intersect them. Let's intersect these two as well. Okay, except for now, I'm going just to extend this line, and Here I can see that splines actually have different diameter than axle itself. So I'm going back to fit entities, create here underline. Here I can spot this blend line. Okay, good for now. Let's go to sketch, use corner trim to intersect these. Extend this one. Also extend this one. Let's enable our axis. Close boundary on one side. And actually let's fit another line here. Okay. Back to corner trim tool. Extend. And add last line to close boundary. At this moment I can create revolved feature. I can actually merge it already. So, okay, good so far. At this moment I'm going to hide our cross sections and hide axis. And I want to create another cross section here on the bottom. To recreate our splines. Let's make section view. And here, somewhere here we need to find some better geometry of our spline. Okay, so I guess I'm going to go with this one. Let's go to sketch entities, intersect them. Oh, actually we can fillet them as well. Okay, good. Let's extend like this. I'm just going to create here an arc to cap them. So let's disable our section view. Hide our plane and create extrude from now. But I want to hide bodies at the moment. So in this case I'm going to make them longer on the other side. I don't need to merge it because I want to use this as a cutter. So what I need now, I need to hide my main body. I can hide cross section and I have to make a circular pattern. And as direction, I'm going to use base axis. And from here I have to find how many splines I have. So okay, it looks like I accidentally tapped the correct number of these splines. So okay, so in this case I have to select bodies because they are not merging together. Okay, good. So we have these bunch of our spline cutters. I'm just going to hide them for now. Let's go and unhide. My previous cross section. And let's use the same plane to create another sketch right here. Quick surface tab, fit sketch entity. So I want to fit here a circle. And okay, let's fit here another circle and just a tiny line to represent this. Like this. Let's trim all this. So we have these two cutters right now. I'm going to unhide my main body and create revolved cut. So I have to select my axis of revolution, this main one. Okay, like this, good. And there's still one more thing that I have to extract from our scan data. So cross section, and again using the same plane, creating new sketch. Actually, I don't need the same cross sections because just they won't work for me. So let's go to our axis, create another sketch, and I need to reposition this somewhere. Well, for example, here to get the clean profile. And I need one spline more. Okay, this looks good. Okay, so I'm creating new sketch on my right plane, coming here, fitting straight line. Okay. Let's extend this. Oh, actually, I'm going to unhide my axis and I'm going to create a revolved cut here. This will be able to save you some time. So I'm just unhiding all of my spline cutters. Revolved cut, axis of revolution. Click OK. So what I have now, created the correct cutters for my splines. And I have main body of our axle. So again, now I need combine tool. I want to subtract. I want to use main body this, and okay, let's say I have to select all of them. Probably as easier solution here, for example, if we clear this selection, we can come over to our solid body tab. we can select all of them from here. Let's see preview. Click OK. Let's hide our scan data, and here we can see this nice result. I think there is still left just a small, two small features that we actually still have to recreate. Let's find, okay, this cross section should work just fine. So what do I need now? I need to fit one more line here, just to make this chamfer. Of course, you can just go to chamfer tool and recreate it, but probably this is faster and easier, considering we are working with scan data. Just let's say this is more advanced. So cut through all this one. Okay, again, hide my main body. Use the same plane to create sketch, and now I need this drilled hole right here. So let's go with sketch entities. Again, we don't have too much of nice geometry here, so I'm just going to slightly eyeball it. So something like this. Okay, let's unhide axis. And extend these two. Again, close boundary and create a revolved cut. And hide our main body, accept this. So this way it seems that we have created, well, if not completely everything, then most part of our features here. And hopefully you found this demonstration useful. And here we can see the complete analysis. So at this point we can see that actually probably this axle also might be twisted a little bit, because we can see the different deviation on one side to another side. But well, in this case it's like super tiny, and probably this is absolutely normal. And at the same moment we have like repaired the top part where everything now is perfectly aligned, angled, and meets axis of our axle and the bearings. So thank you for watching, and see you next time.